Ladies and gentlemen, welcome to this webinar of Freudenberg Filtration Technologies. My name is Mike C. and I'm with Freudenberg in the Filter Technical Department since almost 13 years now. We expect that this presentation will take some 30 minutes, and the subject of this webinar is the European standard EN 15695. We will talk about the cabin filtration requirements and have a look on solutions for the protection of the operator, so the driver, against hazardous substances. I will also share some experience from the field. If you have some questions during this webinar or you have some comments, please contact your local Micronair service personnel or simply send an email to micronair@freudenberg-filter.com. Our experts are more than happy to answer your questions or to share comments with you. As an introduction into our topic, I want to share this background with you. I think the headline brings it quite well on the point. Pesticides, a necessary evil. As a matter of fact, pesticides that are intended to serve as plant protection products, which in general protect plants from weeds, fungi, insects, or others, are preventing farms from significant crop losses, and therefore, at the end of the day, avoid, for example, an increase of the world hunger. But along with these benefits, pesticides also have drawbacks. For example, based on actual studies, a potential toxicity to humans and other species is expected. People that are exposed to especially high concentrations in the long term have to be protected before getting potential diseases. One example is the farmer during the spraying application, who has the risk of exposure to very high concentrations. And this is now the point when we come to the EN 15695. The purpose of the EN 15695 is to limit the exposure of the operator, in fact is a driver, to hazardous substances when applying plant protection products, so-called PPPs, and liquid fertilizers. The standard is divided into two parts. The first part is about CAP classification and requirements and test procedures. The second part is about filters and test procedures and informations to be provided by the filter manufacturer. The standard specifies 4 categories of caps of agricultural and forestry tractors and self-propelled sprayers, and the relevant requirements and test procedures in order to limit the exposure of the operator to hazardous substances when inside a cap. Before we go into more detail about the filter requirements, on this table, I want to give you a short overview about the basic requirements defined in the standard. The category 1 is not defining a special protection level of the operator. There are no requirements on dust, vapor, or aerosol filtration, or on the regulation of the HVAC system. So in a spraying application, a cap classified as category 1 is not suited to replace any personal protection equipment, so-called PPE, inside of the cap. The category 2 is defining a protection level against dust exposures. So a dust filter here is needed. It is also defined a minimum fresh air flow of 30 cubic meters per hour and a pressurization of the cap to more than 50 Pascal. Or if the cap is equipped with a pressure sensor, that is optionally here, a minimum of 20 Pascal overpressure. In a spraying application, a cap category 2 is suited to replace the gloves, the protective suit, the eye and face protection, but not the filtering mask. The category 3 level, additionally to the dust protection, has to offer protection against aerosols. So the filter performance is increased, and also on the cap, it is now mandatory to have a pressure sensor controlling the minimum pressurization of 20 Pascal. This cap level now is also suited to replace the filtering mask as PPE when you are inside of the cap during a spraying application. But please note, only if you are not exposed to vapors. If gas-tight respiratory protective equipment is needed, the cap category 4 is suited to replace the PPEs during the application. For sure, depending on the material data sheet of the PPP and taking care that nothing different is mentioned over there. So additionally to the requirements of the category 3, here also a filter performance for vapors is defined. But please note, during all other activities outside of the cabin, the personal protective equipment must be worn. In order to avoid contamination of the cabin, it is not permitted to enter the cabin with contaminated personal protective equipment. So now I want to go a bit more into detail about the filter technical requirements. And as the category 4 filter has to fulfill the dust, aerosol, and also the vapor purification requirements, I want to take a category 4 filter with its multi-stage design as an example, because we touch all the mentioned points. So on the first stage, for the dust filters, the requirements on performance are The filter has to offer more than 99% gravimetric efficiency at the maximum possible fresh airflow. The test has to be done with A2 dust in a raw gas concentration of 1 gram per cubic meter. And the test duration is 30 minutes. And here on this graph, you can see as an example the performance of the category 2 filter stage during this test. Plotted against the y-axis 1, you see the pressure drop in Pascal, and against the second y-axis, the gravimetrical efficiency. On the x-axis, you see the dust load. When we have zero dust load, the dP we find is our initial delta P at the maximum flow rate. With increasing dust fed, the pressure drop is also increasing. For example, until a final dust load is achieved. And this depends on the maximum airflow. For example, for 60 cubic meters per hour, under dimension test parameters, this corresponds to a dust load of 30 gram. The efficiency also is increasing with a dust load if we look on the category 2 stage separately. The average has to be more than 99%. On this slide, I wanted to share some impressions from the real operation. To be more precise, here you can see the dust filter stage of a category 4 filter element that was operated in a vineyard and orchard for some 150 operation hours. I always say it in this way. The job of the dust filter stage is to do the hard work and to get rid of the biggest dust portion. Looking at the pics, you find a lot of coarse particles and fibrous dust. To have a good usage of the filter area, it is of help to go for a quite open pleating and allow the coarse and fibrous dust to penetrate into the pleat depths. Then you can ensure to operate the filter a long time on a low delta P level. If you start to clog the pleat tips, the increase of airflow resistance will happen very fast, and therefore it comes to the point when the fan cannot handle the minimum airflow requirements anymore. Beside the fact of dust filtration, in a spraying application, the filter material itself needs also to handle the spraying fog and droplets being created. That's why our experience is that a progressive, structured, water-resistant non-woven material offers also very good coalescing characteristics and therefore the best performance to do the job. In a category 4 configuration, we have behind the dust filter, so our working horse, the aerosol filter sitting. And the job of the aerosol filter is to guarantee the high filtration performance. The requirements basically are the same than for a filter element being installed in a clean room or in a hospital. So the filter has to be qualified according to the EN 1822. The maximum aerosol penetration shall be less than 0.05% before and after storage. This corresponds to a filter efficiency of 99.95% for MPPS particles. In cleanroom industry, this performance level is well known as H13 filter class. The test duration before storage is some 20 minutes. And then we store the filter for 24 hours and repeat the test for another 3 minutes. To repeat the test also after storage, this is not typical for cleanroom filters. But in our case, on the tractor, it shall simulate the resistance of the filter material when exposed to high aerosol concentrations and check if there is any clogging effect. On this graph, you can see plotted on the x-axis the particle size in logarithmic units, and on the y-axis the filter efficiency. The curve has to be above the H13 requirements of 99.95%, here indicated with a dashed red line. As you see, here we find a minimum that is typically at around 100 to 250 nanometers. This is the so-called MPPS particle size, the most penetrating particle size, the particle size that is collected the worst. So for the filter validation, you can imagine we really create a monodisperse aerosol in the MPPS size and check the filter efficiency exactly at this point, because this is the worst point. There's a minimum. This means that the efficiency is not decreasing with decreasing particle size. Particles in the nanorange are even collected with a higher efficiency. And this probably, at least to me, when I was a young filter engineer, sounds a bit like magic, but it isn't. Please allow me a short excursus to the very basic filter theory to explain this effect for the MPPS point. To collect a particle, it is necessary that first of all, the particle is being transported to the collector, in our case a fiber. And secondly, for sure, we need an adhesive force between particle and fiber. That goes back to some intermolecular forces, for example, the van der Waals force. For the increase of the efficiency here on the right side of the curve, the dominating transport mechanism of a particle are impaction and interception effects. And on the left side, there's a diffusion effect increasing the efficiency again. This effect is very strong for particles, especially in the nano range, because they recognize that air is not a continuum, it consists of single molecules, and their motion is a random walk, known as a Brownian molecular motion. As finer particles get, they follow this motion, and so the possibility to hit a fiber is increasing. Anytime I explain this background, it sounds again also fascinating for myself. On this slide, I wanted to share some pictures of the aerosol filter stage after operation for one spraying season in a category 4 cap. As I said, the first stage, the dust filter, has to do the hard work, but it offers also a high efficiency of more than 99% A2 dust. The question now is more really needed? So looking at the aerosol filter, we also see that some dust, especially here in the submicron and nano range, penetrated the dust filter and got collected on the aerosol stage. This is the evidence that for highest protection level of the driver, the aerosol filter stage definitely is needed. Especially these ultrafine particles are actually under the focus, as they might are causing the biggest human diseases. On the left pic, when we compare, it's the right pic, when we compare the raw air to the clean air side, the clean air side as it should be is white. And also under the light microscope, we don't find any particles penetrating the HEPA stage to the clean air side. As the HEPA filter material itself has a very high efficiency, also the airflow resistance typically is high. And to achieve a low delta P in the filter element, we have to equip it with a lot of filter area. What you can see on the left pic is the aerosol filter in so-called mini pleat design for very narrow pleat distance to achieve the lowest delta P possible on the available space. Here on this slide, I summarized the requirements for the vapor filter stage that typically is located behind the dust and aerosol stage. Before the test, the air delivery and filtration system should be subjected to drop and vibration preconditioning. As chemical or let's say carbon filters can be a fragile product, this preconditioning is simulating the operation conditions to ensure a good and robust filter design, not to get any undesired experience like dramatic drop down of vapor efficiency under real operation. The filter has to meet the requirements of the type A. This means for a test duration of 70 minutes, cyclohexane is applied in a raw gas concentration of 500 ppm, and the clean air concentration has to be over the complete test procedure below 10 ppm. On the graph on the left side, you can see how the filter should perform during this test. The red lines here are the borders of minimum requirements, so the curve has to be below the 10 ppm breakthrough for at least 70 minutes. In the shown graph here, we exactly sit on the border. For sure, to guarantee the best driver's protection level, also this test has to be done at the maximum possible airflow. On this slide, you can see the vapor filter stage after the field test. To handle the requirements, in this case, as an example, we are using a special ceramic carbon mixture where during a sintering process, robust and stable blocks are created. As it is vapor being collected outside in the field, inside of this carbon porous structure, visually it is not very spectacular to analyze it. But an important finding is that these blocks resist the operating conditions. No cracks or mechanical degradation could be found, which means at the end no bypass or leakage that would increase the risk of exposure of the driver to hazardous substances. I also uploaded a short video sequence where the vibration preconditioning of the filter is done. This is the test the filter has to survive, and the vapor performance of the filter is tested afterwards. I hope this video works. And as you see, it was also a very heavy preconditioning for a carbon filter. And you can imagine, if you want to survive this kind of test, you need a special solution and a robust filter design to ensure at the end of the day a safe operation outside in the field. The filter technical requirements now are clear. The challenge is to design a filter element in a way that all these characteristics are ensured and fulfilled. In general, the requirements are A multi-stage design is needed to handle these various filter technical requirements and to have the different jobs clearly identified and dedicated to the filter stages. Like in my words, having the filter for the hard work in the first stage, the filter to guarantee the highest air purification in the second, and additionally also the robust vapor filter stage as final stage. All this is needed to fulfill the category 4 filter performance. And here on the picture to the right side, you can see the principle on a mock-up. Everyone who ever installed a filter into a clean room and performed the integrity test knows it sometimes is not so easy, and you need experience to install a filter element really leak-free into the housing. And as we cannot expect from people installing filters into a tractor cabin, having this experience like the cleanroom people have, we need a frame design that allows, let me call it, a foolproof integrity of the filter element into the cab to ensure the highest filter performance. A robust design is needed, as we have seen on the video, and typically a requirement is also the possibility of an easy handling, so that mounting at the roof of the cab with one hand can be feasible. On the pic below on the left side, I made an example for a multi-stage metal framed filter with a recessed flange. I like this recessed flange concept very much because it allows the maximum usage of the available space inside of the cab. And on the right side below, there's a sketch of a multi-stage plastic framed filter with plenum. That can, from design point of view, also have some benefits, especially concerning the leak-free integrity of the filter element into the HVAC system. For sure, auto-customized solutions are possible and can be individually optimized. From the early beginning up to today, we monitored also several hundreds of hours of filter performance outside in the field. I would say we now have also experience with more than approximately 50 different PPPs. On the pic to the right, you can have a view inside of a cab and see the test set up. You can find a dust monitor detecting the dust concentration. The orange device here, this is a PID, a photoionization detector monitoring the VOC concentration inside of the cab. Quite interesting to use are also electronic VOC sensors that are actually under a study, because with this, it's possible to monitor the VOC concentration in the inside and outside of the cab in parallel, and have so a direct link to the protection level of the driver. I will not go into details of the table shown here, but just exemplary, I want to give you a feeling how many different PPPs can be applied during one spraying season of 150 hours in a mid-sized vineyard and orchard. Okay, here I just want to give you a short impression in running field tests. First of all, I have to say, for sure, for a filter technician, there are much worse places to run a field test. And when you are outside, very quickly you will understand what happens in reality during the spraying application. For interpretation of the results you monitor, you have to be aware that there are situations that are the most critical for the exposure to hazardous substances, like the ice stone protection on the picture below to the left side can create a PPP tunnel, or on the right side, the moment when you make a U-turn and drive probably directly through the cloud you applied before. Also, weather conditions like the direction of the wind have a big impact. What you can see on the two pics here to the top. And also the contamination source can be the dust carried inside of the cab from the driver, what you see on the pic above. Here you can find some results created from the dust monitor. Let me explain. The first 20 minutes, the dust monitor was located inside of the cab. And to get a feeling about what is going on also on the outside of the cab, we then took it out and checked the outside concentration level. Generally, inside of the cab, the dust concentration we monitored is quite low, so it's in the low microgram per cubic meter range. There are two peaks visible that are linked directly to special moments. The first one is the moment when we were standing at a PP filling station and the farmer opened the door. The second peak here This was a short moment where the driver was stopping next to me and asking if the device that turned actually into a screensaver mode is still active. Immediately, you recognize the open window on the dust monitor. Outside, we could find some very critical moments that are, I would say, linked to the U-turns of the tractor. Here, the peaks are in the milligram per cubic meter range, and the highest one we found in this case was also close to 12 milligrams per cubic meter. As during the complete test, the concentration inside of the cab was only in the microgram per cubic meter range, these results prove for me the importance and effectiveness of the filter element to limit the exposure of hazardous substances to the operator. On this slide, I want to share with you some results generated by the VOC sensor. As mentioned before, the interesting thing is that we can monitor in and outside concentration in parallel. What we found also in running the PAD in parallel, that the values inside of the cab are on the ppb range. So this is parts per billion. We didn't find a moment up to now where we raised really in the ppm, so parts per million range inside of the cab, which is by factor 1000 higher. And similar to the dust concentration inside of the cab, there are some special moments with the risk of higher exposure to ppps. The blue line here, this is the signal of the inside sensor, and the orange one from the outside sensor. In the moment at the PPP mixing station, when the HVAC was not running, we find an increase of the inside concentration. And after the HVAC started, also in the moment the door was opened, we had inside a higher level than outside. And this happened anytime we stopped and opened the window or the door for a short moment. For sure, during all our tests, we found several interesting moments. But as time on this webinar is limited, I want to come to a last point that I wanted to mention beside all the requirements for the fresh air filter, for the fresh air supply. And this is the importance in using also a recirculation air filter. Because a contamination source can also be the driver. This I mentioned before, who is carrying the dust, for example, on the shoes or on the clothes into the cabin. You can see this again on the picture on the top left side. Typical contaminations are coarse particles or fibers from the ground or from the plants. To achieve an air quality in the driver's comfort range, the air conditioning, for example, cooling, heating, is done with a higher recirculation airflow, let's say up to 500 or 600 or 700 cubic meters per hour, and a lower fresh air flow, for example, 43 cubic meters per hour. This is lower because for sure the fresh air is contaminated. And to get rid of these particles carried inside to the cab, the fresh air filter cannot help. Here the recirculation filter is needed. And the filter technical requirements are a low delta P, a good efficiency for coarse particles, and for sure it has to fulfill the hygienic requirements. Finally, we are quite close to the end of this webinar. I want to give you a short summary. What was it about? The standard EN 15695 specifies 4 categories of cabs of agricultural and forestry tractors and self-propelled sprayers in order to limit the exposure of the operator to hazardous substances when you are inside of the cab. Why it is important? To protect the health of the driver and to limit the exposure of the operator to hazardous substances. Cabs category 4, according to the EN 15695, are suited to replace personal protective equipment during the application. And how is it done? The CAT4 multi-stage filter concept reliably separates dusts, aerosols, and vapor contaminants. It offers more than 99% gravimetric efficiency and has a maximum MPPS penetration of 0.05%. And it meets the requirements of a type A filter. So now we are really at the end, and for me it's time to say thank you again for joining our webinar. I hope it was somehow of interest for you, and in case of any questions about the category 4 filters, but also about all the other filter applications and our, let's say, 360-degree experience, as mentioned at the very first slide, please don't hesitate to contact us under the given contact data. Enjoy the rest of the day and talk to you hopefully soon.